Before you can start using the Microscope-Control software, you need to set up a configuration file that tells the software what devices are connected to your computer and what the function of each device is, and any COM port, connection, or access information for each device. You really only need to do this once when you're setting up. If you change hardware later, you can just edit specific items, and it's pretty easy. If you're setting up a 4Pi system, this is also pretty easy because all we need to do is edit the example file that's already part of the repository, or if you're making a file from scratch, it more or less follows the same workflow. In this video, we're going to assume we're setting up a 4Pi system and go from there. So the first question is, where is the example configuration file and where should I put my configuration file? If you've downloaded or cloned the repository, just browse to Microscope-Control, Hardware Configuration, and then the Hardware Configuration Files folder. This is where the example file is sitting and where you should put your configuration file. Now let's look at the example file and walk through what the different parts are. This is the example configuration file that's part of the repository, and there are 4 main blocks of text. First, the text at the top is just comments that say what the file is and tells the reader that any line starting with a % symbol will be ignored as a comment line. The next block is the name of the configuration. When you run the Start VI, this name will appear in the drop-down menu that lets the user decide which hardware configuration they want to load. The third block of text is just more comments that tell the reader some information on the format of the file and let the reader know where they can find a LabVIEW VI for editing the file if they want. The last block of text has the actual configuration information. This is set up so each line defines one device. For example, the first line in our example configuration file is for the lower shutter on our 4Pi microscope. Now, getting more specific, each line is made up of 2 JSON string arrays separated with a comma. So here I've drawn a red box around the first array, and now I've drawn a red box around the second array. Let's talk about the first JSON array first. The first array has information listed in the comment I've highlighted in green. Specifically, the first array has the company or vendor that makes the device, type or class of device, the device function, and finally, the path to the low-level device engine that we need to have running to control the device. The second JSON array has the COM port or device connection information as a string array. In this case, our shutters are connected to an NI DAQ board, which is on the system as dev1, and the shutters are connected to line 0 of port 0. In this case, we have an array with one element, but if you look farther down the file, you'll see one of the piezo stages has its device name and then the names of the axes as the connection information. So now that we have an overview of the configuration file, how do we edit it? And there are 2 good options. First, you can open the file in Notepad as I've done here, or your favorite text editor, and directly change whatever you want. This is nice when you're setting up and you want to quickly put a % symbol at the start of one line to comment out a device that's not set up yet. The second option is to use the VI located in the hardware configuration folder called Write Configuration File. This loads all the configuration information into a format that might be easier to read or edit. Both options work, so you can do whatever you like more. So let's get started setting up our configuration file for our 4Pi system. Now, let's open the hardware configuration folder within the main directory, and then open the hardware configuration files folder. Let's do a quick copy and paste to duplicate the example hardware configuration file. And let's change the name of the hardware configuration file. I'm going to call mine 4Pi microscope, and then I'm going to copy that name because I'm also going to use it inside the configuration file. So let's go ahead and change the configuration name to match the file name. Now the example file is already set up for a 4Pi system, but we still need to update the paths to the device engines. Right now the paths all start with 3 dots, so let's use the find and replace function to update all of these. So I'm going to browse back to the Microscope-Control base directory, and then I'm going to copy the absolute path to that directory on this computer. Now I'll go back to the configuration file, and we need to replace these 3 dots at the beginning of each device engine path. So I'll go in the Edit menu, I will choose Replace, and now I will paste in the path on this computer, but this is JSON, so we need to change those single backslashes to double backslashes. And then hit Replace or Replace All until you've updated all the device engine paths. Now that we've updated all the paths, be sure to save the changes to this file, and let's continue editing with the right configuration file VI. So let's open the hardware configuration folder, and then open the right configuration file VI. Let's click Run to run this VI, and let's click Load File, and select the configuration file we just created. Now I've already created a list with all the COM port and access information for my 4x microscope, so I'm going to pull that up, and then we just need to transfer that information to our new configuration file. So I'll start typing the info in. Our shutters are on lines 29 and 18. Our sample XY stage is on COM 17, and here we also have to include the axes names, which in this case are 1 and 2. Now the next device doesn't have a COM port, and we named it XYZ stage using NI max in a previous video, so I'm going to set that name here and then add the axis information. In this case, the sample Z axis is named C. Now we'll keep copying over COM port information until we get to the next device that has multiple axes. Now this device is part of the chassis that holds controllers for an XY piezo stage and a sample Z stage, and just like before, we already named this using NI max, so we need to put the name in and then add the axes names. I'm going to continue copying over the connection information into the right configuration file VI. And once we're done with that, I'll scroll to the top and click Save File and select the 4x microscope configuration file and click OK to overwrite the file with the new information we just entered. So that's pretty much it for setting up our configuration file. Now, if you're using one of the popular CMOS cameras from Thor Labs, Edmund Optics, or IDS for an objective lock on your 4x system, I'd like to switch gears and just make a quick note about how you find out the camera ID. So it happens sometimes if you have more than one of these IDS cameras plugged into your computer. When you open the IDS camera manager, you'll actually see that they both have the same camera ID. Now, this creates a problem when you try and connect with one of the cameras. So the easy way to fix this is to click on the camera information button, and there's actually a place where you can just type in a new camera ID. So just change the ID to a different number, and then take that number and put that as the connection information in your configuration file. This work has been entirely supported by the Wellcome Trust and carried out at the Gurdon Institute, which is part of the University of Cambridge, UK. Go ahead and click the link on screen now if you want to jump to the next video where we introduce the device panel, which is sort of like a dashboard for controlling which devices are running. We'll be using this to start testing the devices ahead of actually launching the software.